Hi, I'm Chris. We are in section 4 of SAT Practice Test 3, and we're taking a look at questions 10 and 11 here. Now, both of these questions refer to the following information. So we see a table of values, and then in this description, they tell us the chart above shows approximations of the acceleration due to gravity in meters per second squared, where they show us, this is just a representation of the units that they're talking about. For the 8 planets in our solar system, the weight of an object on a given planet can be found using the formula W equals mg. So this is the formula they give us, which is likely going to apply to one, if not both of these questions. And they will tell you, whenever they give a formula, they will tell you what those variable representations mean for each variable. So we see they tell us W is the weight, m is the mass, and g is the acceleration due to gravity. So here, this acceleration due to gravity, in this whole column of values here in the table, they're really just giving us different values of g for the different corresponding planets. Okay, let's jump into these questions. For 10, it says, what is the weight in newtons of an object on Mercury with mass 90 kilograms? So we know it's going to relate to this formula that they gave us. I'm going to write that real big at the top, and then we can zoom in here on number 10 and see if we can fill in the appropriate values. They say, what is the weight? So this is what we're solving for. That will remain as W in our formula. And then they give us a mass of 90, so we can plug that in for mass. And let's see if we can figure out G. Do they tell us a value of G in the question? No, they don't, but they do tell us we're talking about Mercury. So we can reference our table, and we can look at the value of G for Mercury in that table, which is 3.6. So here we will have 90 times 3.6, and from there, it's just a plug and chug. We plug in 3.6, we multiply it out. Again, it's calculator section, so we can type that into a calculator as needed to get the exact value, which comes out to 324. Answer choice D on number 10. So 10 is pretty straightforward. 11 is going to be a touch trickier. And again, it's still going to likely relate to this general formula, so it's never bad to have that right in front of you when you look at the question. And for 11, it reads, an object on Earth has a weight of 150 newtons. On which planet would the same object have an approximate weight of 170 newtons? Okay, well, let me try this formula. So W equals mg. And let's go one statement at a time, because anytime you can do a little bit of math, it's really helpful to at least provide clarity, maybe fill in a numerical value for a variable. So let's start with that. Earth and a weight of 150. Okay, so if I plug in 150 over here, let's see if I can figure out anything for m or g. Well, they tell me it's on Earth. Let's see what values we have for Earth. So back to our table. Here it shows that for Earth, we have a value of 9.8 for g. So if I know that g is 9.8, I can use that to hopefully solve for m. So I would have 9.8 times m. And let's see what that comes down to. We can divide both sides by 9.8 on this. And if we do 150 divided by 9.8, we get 15.3 for m. Okay, so let's take a look here. It says, on which planet would the same object have an approximate weight of 170 newtons? Okay, so now we have a new value, which means we're likely going to have to apply that value to this same formula, but we're going to do it a second time. We're still dealing with W equals mg, but now they're changing up some of the values, but some of the values might stay the same. Let's see. 170 for W equals, now they're asking about the planet here. Which planet? And the information that we have that relates to the planets is from this table. So all of these values are going to be planet specific. And all of these values, as we said from the beginning, are values of g. So we are solving for g. That's our unknown, which means we have to have some known value for m. And as I look over here, I don't see that given in this second part of the question. Let's see if I have an m that I can use from anywhere else. And hopefully we can recognize that we do. this value for m, our mass, can be plugged into this equation. Because we have a known mass, we can plug in 15.3 for m, and we are solving for g, and now it just becomes simple algebraic equation where we divide both sides by 15.3. 170 over 15.3 is going to give us 11.1 repeating, or 11 1/9, which is our value for g. And our answer choices just have the planet names, so we're going to have to reference our chart and see which of those planets has a value of g of 11.1. And if we look down our list, oh, there it is. That's Saturn. That's answer choice B for question 11, and we are good to go. So just keep in mind that when they give you a formula in a question, and I'll color code this a bit, but you see W equals mg, remember that very commonly you might have that formula apply to more than one question, and even within one question, like we saw in question 11, you might have to use the same formula more than once to find an unknown, which is exactly what we did here.